So hi, everybody. My name is Katy Sadwoski, and I'm super happy to be hosting our ETL developers panel this morning. So the focus of the session is on OMOP ETL development. For anyone in the audience who's less technical, ETL stands for extract, transform, load. So an OMOP ETL is the process through which we extract data from a source, that might be an EHR system or a claims database, transform it into the OMOP CDM, and then load it into a data warehouse where it can be accessed and used by analysts and researchers. That transformation step in particular can be very, very complicated. However, there are lots of very useful open source software tools available that can help make it easier. And the goal of today's panel is to showcase 5 developers doing great work in the open source OMOP ETL space. I'll quickly run down our agenda today, starting with the intro, that's right now. Then we're going to dive into the lightning talks. Each developer is going to present for about 5 minutes on their project. And then finally, we're going to do some Q&A. And we invite all of you to ask any questions you might have about the work presented in the lightning talks or about OMOP ETL in general. I even invite the panelists to ask each other questions. I think it's pretty rare that we have that much OMOP ETL expertise in one meeting all together across lots of different institutions. So I think we should really take advantage of this opportunity to share knowledge. And just one note, please save your questions for the end. And then once we finish the lightning talks, use the raise hand feature if you want to ask something. And then, yeah, finally, we'll just do a little break at the end to give folks some time to chill out before the next session. And here's our panelists. Everyone's going to introduce themselves before they speak, so I'll save you the repeats, and I'm going to turn it right over to Vishnu to kick us off.
I'm going to blitz through this, saying that we said it was a lightning talk. Thank you very much for inviting me to this. I'm honored. I'm just looking at Paul's presentation of the number of people that are part of this community and how much they have contributed. I'm well and truly a very, very early developer, if you like, within the community. Let's see. Right. So I am a consultant surgeon at Lancashire Teaching Hospitals. We're located in the northwest of England. That's part of my role. That's about 30% of my role. The remainder 70% I work for digital. I lead the Lancashire and South Cumbria Secure Data Environment Program. Anyone from the UK will know that we have a large nationwide program for building trusted research environments. I also hold an honorary chair at Lancaster University. So we are a major teaching hospital and a regional trauma center. We have 2 sites. And today I'm going to speak about about our data landscape. I don't think it's particularly different from a lot of other big hospitals. How we went about transforming into OMOP, and very briefly touch upon the analytics infrastructure that we've got deployed alongside that. So this will be familiar for most people here. A patient journey through a hospital is fairly complex. When a patient comes in, some of their data goes into an EPR. They go have a colonoscopy, the data sits in a different clinical application, the back endoscopy, radiology sits in a different system, cancer data sits in and they're all, our EPR sits, data goes into an Oracle warehouse, a lot of our cancer data goes into SQL Server, our laboratory data goes into Sybase, which actually is in German. So one of my engineers has learned German to write the SQL queries to map data in. And when you take that outside of the hospital, the number of places that we store data about our population simply explodes. It's unmanageable. So I went on we have access to the OpenAI endpoint, and I said, hey, depict the OMOP common data model as a person-centric data model. And I came up with these 2 nice graphics. And this ties in nicely. I think the one on the right ties in nicely with the Odyssey community. It's the superpower of the community, bringing in all the data silos together into one big. So I quite like that. So we started, as most ETL programs for OMOP work, we started looking at White Rabbit first. Our Oracle warehouse has got 1,000 objects in it, undocumented. White Rabbit failed to run successfully on it. We tried to select it. We spent 2 weeks with White Rabbit, but we didn't know how to make it work. We looked at Rabbit in a Hat, and then we settled on. We looked at Rabbit in a Hat, and then I said, hey, this is what our data lineage looks like. Part of our data lineage looks like on dbt for our ETL. So you can see how complex it is. And this is about 80% of our data for one hospital. So this shows, each node there is a table or a view, and from the left to the right, it takes our source data and puts it into OMOP. So you can see that it's challenging doing some of this work. So we picked a tool called DBT. It's an open source tool. I'll drop some links in the chat after my presentation. It's called Data Build Tool. There's an open source version. There's a hosted cloud version as well. We chose to use the open source version. And what it allows you to do is build your entire ETL as SQL with very minimal Ginger templating on top of it. So anybody who comes from a Django or Python background will know Ginger. The learning curve is very, very shallow. I'm not sure if my data engineers are here today. They spent 2 weeks learning it. So they had really good SQL experience. 2 weeks later, they were writing DBT code. It's allowed us to work as a team. It gives us data lineage built into it, documentation, it's self-documenting. And if I think I'm about 2 minutes into my presentation. I may even squeeze in a live demo if I can. So we built multiple layers. I'm sure everybody's got a different way of doing it. So we have a multi-layered modeling approach to our ETL, and the layers are based on what functions happen at each, what operations happen at each layer. So we have a source layer, we have a vocabulary layer, we have a staging layer, and finally we have an OMOP layer. And I'll drop the entire DBT lineage is published online. So you can go and browse everything that we've done, every line of code that we've written, and all of the lineage. So I'll drop that in the chat as well in a minute. So you can have a look at it. So we'll start with the vocabulary. We used Usagi. Usagi has been fantastic for us. We use Usagi. So the Usagi outputs get saved as CSV files, and DBT has this concept of seeds. Essentially, you save the CSV files into Git, and DBT will automatically convert those into tables in your warehouse. So so we have various domains. We use Usagi, the outputs became seeds. Seeds get incorporated into the ETL lineage. Here's a little example of one particular OMOP table or person table and the number of different sources that go through the transformative process, going from source into staging into vocabulary to finally make your person table. That's possibly one of the simplest lineages there. When you start looking at things like measurement or observation period or drug error, it gets really complex fast. What DBT allowed us to do is use OMOP for more than research. So we've been able to reduce our refresh time of OMOP. I think we start off on a monthly. Now our OMOP instance refreshes every morning. So 9 o'clock every morning, our OMOP data is as current as of midnight the previous night. And this is a little a snippet of the lineage that shows how we've gone about doing our incremental refresh. So only the new rows are transformed into. This is not for all the models. This is just for some of the biggest tables. Some very brief summary stats. We've got about 1.8 million patients, 400 plus measurements. These obviously increase by about 1 million a day, I think, at the moment, or 500,000 a day. We bring in multiple data sources. Like I said, it refreshes every morning. We're using it for direct care intelligence as well as research. What are we doing next? So that bit that I've just shown you is our bronze layer. So we're now building something called the OMOP medallion architecture. This is where maybe we can work with the community, because once you've got data mapped into OMOP as bronze, then the silver and gold layers, whatever we build, will be useful for the rest of the community if you're using DBT. And if you're doing something, that will be useful to us, because some of the operations you have to do to get your OMOP layer through the data quality checks to make it network conformant are the same. Have we got 1 more minute? Katy, did they? Lost. Perfect. We put a poster in the OHDSI Global Symposium, and we couldn't travel to the States, unfortunately, last year, but I made sure, thank you very much for the OHDSI community for putting our poster up. And there we are. I've got a little arrow pointing to our poster there. My data engineer is really, really shy. That's the top of her head there. I'm not sure if she's here today. Quinta Ashcroft, she's done about 80%, 90% of the work on this. So that's the ETL side of things. So, I did say the title of my presentation was the hard way is the easy way. Yes, there was a steep learning curve with DBT and the way we went about doing things. But now that we've done it the hard way, bringing in additional data sources is trivial. And we're now going out to map another hospital's data into OMOP. And our strategy is that we'll have one OMOP instance between the two sites. And there are 5 hospitals in the region. And our vision is that in a few years' time, we'll have a single OMOP instance for the entire region. That's the data. The OHDSI stack is deployed on Kubernetes at the moment. And the OHDSI stack forms part. I think, Paul, you spoke at the data science meeting at Lancashire Teaching Hospitals maybe 3 years ago now, when I presented our Jupyter Hub instance on Kubernetes, and you said your precision medicine platform, I believe, runs on Kubernetes as well. So our OHDSI stack is now running on Kubernetes. We are engaged with the Databricks working group because our OMOP data sits in Databricks. There are some issues with compatibility, but we'll work with the community through that. So this is not, we say DevCon. This is not about the software. This is not about the tools. This is very much about the people. So for me, all of this has allowed me to kind of build up the skills within the region around a modern stack. My 2 data engineers are doing PhDs, but they both, one of them is focused, the entire PhD is focused around the data engineering. But we've been able to secure multiple grants. We are a founding member of the UK OHDSI chapter. We're looking forward to engaging more with the community and learning with you guys. I think I may have run out of time, and I may keep the demo for a different day, Katie.
Yeah, and maybe during Q&A, someone wants to ask for a demo.
Perfect. Thank you very much for the opportunity, though.
Thanks so much. All right, next up, we've got Roger.
Okay. So thanks for having me, Katie and Paul. My name is Roger Carlson. I work at Corewell Health as a senior data analytics engineer. Corewell Health is a large healthcare system servicing central and lower, basically all of central and southern lower Michigan. So what I'm going to talk about today is moving OMOP to the cloud with DBT and Snowflake. I really appreciate Vishnu's presentation because it simplifies mine a great deal. So just remember all the things he said about DBT. And we presented a board here at the 2022 symposium. So our OMOP instance was special purpose built for a network study called the All of Us Research Program, which was funded by the National Institutes of Health here in the U.S. And for it, we enrolled about 12,000 patients. Our legacy system, since we are a Microsoft shop, our legacy, and I should say our source is Epic. So we were sourcing it from Epic Clarity. And since that was in SQL Server, we built our OMOP instance using SQL Server and SSIS SQL Server Integration Services as the orchestrator. But we really had a hodgepodge of tools. I mean, we were using Management Studio, SSIS, Visual Studio, RedCap, some Oracle, RStudio, Tortoise SVN, and even some custom-built Microsoft Access applications. These were all desktop applications, but somewhere in the around 2020, late in the year in 2020, our organization decided that we were going to move into a cloud computing era using Snowflake. And so we looked at a bunch of different ways to orchestrate Snowflake and came up with DBT for the reasons that Vishnu talked about. Also, Snowflake recommends DBT, so they're very tightly tied together. They're not owned by each other, whatever, but they are. That's what they recommended. So Snowflake is a cloud-based database platform. In our case, it's running on AWS, but it can run on Google or Azure. And DBT is a data orchestrator. It's built around Python. You don't need to know how to use Python. You really only need to know how to use SQL. And so, rather than this hodgepodge of tools we had before, now we're using mostly open source tools like Snowflake DBT. We're using GitHub, still using RedCap. VS Code to Beaver and RStudio. So it's a much simpler data set, and it's all open sourced. So our timeline for converting was roughly 13 months total from inception to actually running production for the all of us. We had 2 people working on it, myself and a colleague of mine, and roughly 21 person months involved in that time. And we did this in 4 phases. Phase 1, we moved our database from SQL Server to Snowflake, and that took roughly 8 months because we were just learning Snowflake, we were just integrating Snowflake, trying to figure things out as well. So basically, from April to December of 21. We also upgraded our OMOP version from 5.2 to 5.3.1, which was the version that all of us was using. So, excuse me. So that was phase 1. Phase 2, then we converted our SSIS process to work against the Snowflake database, and that took about 3 months. From September to December of 21, and it overlapped phase 1 too. So we were able to work in both of them at the same time. And then phase 3 took another 4 to 5 months, and we converted our SSIS process to DBT. And so that, from by July 7th of 2022, we were able to do our full production run and send the data to all of us. Phase 4, if you look in our workflow comparisons on the screen for SSIS and DBT, the ones under SSIS that are marked red were manual processes that we had to do because we weren't able to automate them in in SSIS. We were able to automate most of those processes in DBT, including pulling the vocabularies, pulling our OMOP patient list from REDCap, loading, processing the data, and then loading the CSVs up to the All of Us Google bucket. Early on, we were pulling data out of Snowflake down to our local system and CSVs, and then uploading them to the Google bucket for All of Us, which didn't make any sense because it was in the cloud to begin with, and so it's relatively simple to transfer from one cloud bucket to another, and so that works really, really well. In terms of runtime, you can see that using our legacy system took about 1 hour and 50 minutes, only doing those things marked in green. And when we switched over to DBT using Snowflake, it went down to 5 minutes. Now this is for the 12,000 patients that we had in the All of Us program. So that was a huge decrease in processing time. And then in addition to that, we added our phase 4 in there, that automatic stuff, and that raised the processing time from about 5 minutes to roughly 9 minutes. So still a huge decrease in efficiency, not a decrease in efficiency, an increase in efficiency. And so we are now, our next phase is to build this to work against our entire patient population. And I wanted to have at least a test run of that to give you some idea of how that works. But we're not quite ready for that yet. We have been able to run 100,000 patients, and our base process, without the uploading and everything, went from 5 minutes to about 20 minutes. So a 4-fold increase in time for an order of magnitude more patients. And so that bodes really well, I think, for running the 1 million to 5 million patients that we're going to be running ultimately. that's really all I have. If you have any questions, you want to contact me at Corewell Health, we're always glad to talk to you. And if Katie posts some of these, slides, I've got some links to more specifics about those products. So that's all for me, and I'll send you back to Katie. Thanks.
Thanks so much, Roger. And yeah, all the slides and the recordings will be posted on OHDSI website after the event. And I'm going to turn it over to Georgie, who, by the way, is calling in from Australia very late at night. So thank you so much for making the time.
Hi, yeah, it's 20 to midnight here. So yeah, that's just to explain, if I'm a little bit woolly in the question session later, that will be why. But yeah, thanks for having me. I don't often join these calls because they are at very inconvenient times. So it's nice to have an excuse to tonight. So I work for SPHERE, or Maradulu Budiari Gumal, which is a multidisciplinary research network that spans across southern Sydney. And I sit specifically within the Ingham Institute for Applied Medical Research. And the applied bit in this context just means that all the work we're doing there really addresses practical challenges specifically encountered in the clinic. This just means that everything has a really translational focus, and we're looking for practical solutions for improving healthcare delivery and outcomes. These are the broader themes under which our program of cancer research is structured. All of the domains do have some kind of data element involved, but the observational data space is definitely concentrated under my area of focus, which is reducing variation in clinical practice. And in an effort to facilitate this day-to-day, I spend about half my time working on delivery of an OMOP-centric cancer data platform called SAVAR, which is a contraction of cancer variation. And these are our current stats, if you're interested. And you know, that little box represents so many different pieces of work in reality, but I'm just going to describe one current area of focus just to set the scene for what I want to demonstrate. So Marin in the middle here is an oncology specialist dietitian. And she's leading the co-design of dietetic-specific business intelligence visualizations for the detection, highlighting and prioritizing of variations in practice, specifically in the domain of head and neck cancer. And I call this piece out specifically because I think it's an example of a really great low-cost, high-value supportive care intervention that delivers a proven improvement in outcomes for a really specific but very small population with those complex dietetic needs. And I really wasn't sure how much background I needed to provide for this part of my talk, but just in case you aren't familiar with ORMs or object relational mapping, there's a fair amount of richness and complexity underlying all that. So I'm just going to take a minute to sort of whip through a little bit of the conceptual grounding. You know, starting with the actual database, I think it's pretty fair to assume everyone has a good mental model for that part. But then there's the application layer, which is where we describe in code a representation of the underlying data model, which allows us to interact with the database records directly as instantiated Python objects. And so what does that actually look like? If we look at the mapping of the concept table for a second, don't worry about the details. Hopefully it's not that hard to kind of draw a straight line between what you know of the OMOP model definition and what's rendered here. But for our purposes, it's just enough to remember that the table definitions are expressed as classes, and you get columns as properties of that class. And the column mappings define the details of the things that underpin that, like the keys and the data types. And finally, the abstraction, which is kind of the guts of the ORM itself, which provides a translation mechanism between the back and front ends of the stack. And it does things like converting Python code into dialect-specific SQL, or instantiating Python objects that represent the results of the executed queries. So great. Why? Well, for one thing, Python objects are way more expressive than the database rows themselves, right? So analysts, we always need to make decisions over and over again when we're applying conventions in the ETL, I think, as well as the final analyses. And we often find ourselves taken by surprise down the line as a factor of ways that we have interpreted these for implementation sort of at the starting part of this process. And in practice, a richly expressed relational algebra can turn many of these decisions kind of into a set and forget sort of situation, with the side benefit, I think, of making the ETL itself inherently validatable at design time instead of just post hoc on the transformed data. So for instance, a concept object that's returned via a unit concept ID has enough context to know that it needs to behave differently to one that was returned via value as concept ID, if that makes sense. This can even extend to the concept object having different behavior depending on further relational details, such as dates or age variables. And finally, here's a couple of specific use cases why you might want to actually apply this. The first here is what I just mentioned, so bringing these data validation checks further up the ETL pipeline. a trivial example, obviously, but we use the validates decorator to intercept an event when an object is created or modified in sort of user code. And in this example, you raise an exception, so it's impossible to actually write improperly formed records to the database, or you choose to intercept and handle and modify the incorrect data before even writing it out. And if you need to reference vocabulary tables or perform domain checks, things like that, you can employ like a class level method, which pulls in additional context when instantiating the class. And it means that you do marginally slow down the application setup, but overall it still performs really, really well because the classes are only imported one time, whereas the validators fire every time you create the object. So the trade-off's pretty easy to make there. And here's a few more examples showing how it's possible to provide a validation for one field relative to another within a table, and also how you can customize the actual event that the validation scripts listen for, which is useful when you want to validate complex objects, such as the episode objects, which are built stepwise. So another use case that we use this for, this is a really simplified version of our visualization stack. And there's a couple of reasons why I like to do it this way, but the main reason is that it's very loosely coupled into layers, right? So it means you can build and reuse the core application logic in multiple places just by changing the way that we interact with the publish API. Here's just an example of that API and how it gets rendered. I just always like to include, just in case anyone thinks I'm showing real patient data. But here's an example of where the same underlying condition logic gets applied as either a normal condition by the condition schema, or you can render it as a cancer-specific schema by applying different serialization logic, starts to pull in the modifier objects as well and nests these below the parent JSON. And this one is one of my proudest problems I've solved through the ORM approach, which is handling of polymorphic relationships between the measurements, observations, and episode events, each of which can point to a number of different target tables. And so having an intermediary class like this, it abstracts away that complexity so it's hidden to the end user. This means that you can conveniently grab all episode events as a collection, and you get that directly via the events property, instead of needing to handle and flatten each joins against each individual target. And the logical conclusion of this is this query, where you can return an individual, all of their nested events, and all of the episode events assigned to those episodes within a single call. And the final one here, these are just a few examples of how we've implemented extended properties to build in a convention logic within the data model definition itself. So it takes care of all of the logic of handling modality of treatment of episodes here. So again, it ends up being impossible to misinterpret conventions. So if you have an agreed implementation of the most important ones, and I've really spent the least time on this one, but I think it has a ton of potential, although we have to really carefully balance the considerations of and performance implications. And finally, I've put this out as a beta version of the libraries. If you want to have a play, feel free, and please let me know what you think. Just do keep in mind it's definitely a beta version, and so it's not a stable code base. So things may shift underneath at this point, but I hope that somebody finds that useful. And I think I may have lost connection in the middle there, but hopefully you got the gist of it.
No, we had you all the way through. Thank you so much.
Oh, great.
And
my VPN started to reconnect, that's all.
Okay, no, all good. So we'll turn it over now to Sam.
Right, good morning / afternoon, everybody. Thank you for inviting me to join what's an excellent panel. Really excited by everything I've seen today so far. My name's Sam Cox, and I'm talking today from my position as technical lead for the Carrot tools. Now, just a little bit about me, just to begin with. After a mathematics undergrad, I did a PhD in maths and geology, looking at modelling the flow of the mantle. That really piqued my interest for high performance computing, and from there I became a research software engineer, which I remain to this day. Nowadays I am in Nottingham, the UK, and I've moved into this, rather than geology and HPC, I now do much more in the field of health data and trusted research environments, things like that. And I'm also currently on 50% secondment to Health Data Research UK, an organisation here in the UK. Today I'm going to be speaking about the Carrot tools, which were largely developed by a big team at Nottingham, Dundee, Edinburgh, and a couple of other places, and continue to be developed to this day. And yes, the Carrot naming is a gentle sort of hat tip to the OHDSI Rabbit naming convention. So what are the Carrot tools, and why did we build them? So gaining access to healthcare data, certainly in the UK and many other places for research purposes, can take a very long time. You can be looking at 6 months or more to get access and all the various governance approvals in place. When you're trying to convert many data sets from disparate places to OMOP kind of at scale, this is an enormous barrier, particularly if you don't have OMOP experts within each organization who already has access to that data. The carrot tools are architected in two parts. We have an internet accessible web app here and a Python ETL tool as a second part. Together, they allow external OMOP experts to design OMOP transformations for datasets using only metadata, not the row level data. And then the ETL process can be run by anybody with a simple command line. So this means because we don't give access to outside OMOP experts to the row level data, then the governance approvals that the architecture requires are much lower, and that's hopefully faster to acquire. So that helps the whole life cycle to move a lot faster from having data to having OMOPified data. Now, this wasn't possible previously, so that's why we ended up building the carrot tools. Now, the original use case was in the area of federated data discovery, where datasets can be remotely queried to provide safe, non-disclosive information about their contents. Particularly, this is in the research sphere, and so we want to enable researchers to decide whether to pursue a lengthy full access data access request, having the knowledge that hopefully the data is what they wanted. Converting to OMOP is a vital step in that process, but data discovery works best also when the OMOP mappings that are being used are somewhat kind of limited, sort of using a standard subset of the full breadth of the vocabulary. So we built Carrot not only with that split architecture, but it also is built to share and to reuse mappings between datasets, what it's previously seen, and also to provide feedback looking across multiple datasets to see whether they could perhaps align on a smaller subset of possible OMOP concepts. It was important that we automate as much of this as possible, so mappings are not only reused when the system's already seen something similar, but also recognize vocabs are automatically mapped to their respective concepts. Oh, have I just lost my screen sharing?
Yes, you have.
Yeah. Let me restart sharing. Right, double checking that's okay.
Yeah, you're back.
Yeah. Okay, good. And finally, our ETL tool down here that actually runs and does the transformations requires no SQL from the user, but instead it leverages its internal ORM to build and apply rules. Of course, that does bring some limitations. We can't build arbitrarily complex transformations without the power of SQL, but typically, certainly in our use cases, this limitation is typically outweighed by the convenience of avoiding the use of SQL by the user. So what does this look like in practice? A very short demo here. So here we have a data set and it's got a table of symptoms. Here we click on the headaches one here. This has been uploaded into our system, and you can see that headache has been automatically mapped by the system because it's already seen that previously. However, the dizzy entry here, it hasn't seen that before, so we can just enter that ourselves. We pop in the OMOP code, click add, we see that that's identified the code, and then we can go and check that that has now generated some rules that we'll be able to apply to the data later, and then we can download our rules as a JSON file. Okay, so that's essentially, in a nutshell, our very first tool. Everything that does, that mapping rules file can be sent to sit next to the original data set, and we could then run the transformations there. Just to sort of highlight how important it is to automate things, this is a single field in a single table in a single data set, and here the system's automatically mapped 2,500 ICD codes to OMOP. So that's just leveraging the existing power of the Athena database. And then finally, with a single line in a bash command, we can run the transformation. So we tell it where what rules to apply to what data and where to put the output. And 5 seconds later, we have 30,000 transformations have taken place. Many of us are developers here, so this is what our stack looks like. We've got our 2 tools, Carrot Map of the web app. It runs in Azure. It's got containerized Django backend and Next.js frontend with a Postgres database behind it, and then the ETL tool that has to run inside the data owner's environment. That's a simple pip installable Python package, but with pandas as well. This is just a kind of sample of some of the data sets on the left-hand side. This is typically UK focused, but some of these things like Public Health Scotland, Generation Scotland are very, very large data research data sets. On the right-hand side, some of the projects and institutions that are using it. So the CoConnect project, which was one of the main drivers for the development of the Carrot tools, that has made more than 10 million patients worth of research records available through data discovery. We're also integrating with things like the East Midlands SDE as well. And finally, I just want to say thank you to a huge number of people. Don't really have time to thank them all. Developers, designers, and our brave beta users, project leads, and some of the organisations that have helped to fund this. And we are continuing to develop. Thank you very much for listening.
Thank you so much, Sam. And last but not least, we have Peter to talk about Rabbit in a Blender.
My name is Pieter-jan Lammertyn. I work at the AZ Delta Hospital. That's a hospital in Belgium. And today I talk a bit about Rabbit in a Blender. When we started a couple of years ago our journey into the OHDSI world, we started looking at the tools that were available, and we saw that for the ETL implementation there were not much available. We were running everything in BigQuery on the Google Cloud, and we also started working with Usagi, but we could not sell it to our physicians in the hospital. So one of the first things that we did was make a modern web version of Usagi that loads and generates the same CSV files, but more on that tool a little bit later. The name of that tool is Koen, and Koen is West Flemish slang for rabbits. So we stay in the rabbit scene. So once we didn't find a tool that was suited for us, we thought, yeah, well, let's design one our own, and that was the birth of Rabbit in a Blender. Why the name Rabbit in a Blender? Because an ETL tool is like putting all your data in a blender. Once we started doing some ETL tasks and started running the data quality dashboard, we saw that it took a lot of time. In our instance, it was taking like 3 hours to run. So we thought, well, okay, well, why don't we also do the data quality and implement DQD and Achilles? So we also put those tools into Rabbit in a Blender. So what is Rabbit in a Blender? Rabbit in a Blender is just an ETL tool. For the moment, it's a command line tool written in Python that transform your EMR data to OMOP. And yes, no rabbits were harmed. You can find us in the link below on GitHub. So how does it work? In a previous presentation, we already saw the middle layout, bronze, silver, gold. That is a data lake layout where you have a raw zone where all your raw data is your EMR data. You have a work zone where your intermediate tables, your housekeeping tables are, and then in the gold zone, the OMOP zone, we put the final OMOP tables. So Rabbit in a Blender takes some SQL queries, takes the Usagi CSVs and some custom concept CSVs, does his magic, and the result is a fully operating OMOP. How does it work? We looked into it and we thought, yeah, let's keep it as simple as possible, because an ETL process is very difficult. And we thought, yeah, if we now start from a folder structure that is the same as the OMOP tables. So for every OMOP table, we have a folder, and in that folder, we put the SQL queries, like above for person, you have a patient query, for instance. And in those folders of the OMOP tables, we also create a folder for all the concepts columns. For instance, measurement, you have the measurement concept ID, create a folder for that. And in that folder, we then create our Usagi CSVs. And if you want to create an Usagi CSV, yeah, then you require those 3 columns, the source code, source name, and source frequency. So you better create also a query to that, you put it all in that folder. So that's how you start. And you also add a custom folder if you have custom concepts. So it's a folder layout, 3 levels deep. The folders of your OMOP tables in that OMOP table folder. Then you have folders for every concept column, and in a concept column folder you can have a custom concept folder, and you put in there the CSVs and the SQL queries. So the ETL tool itself is like a 2-stage rocket. The first stage, if you look at the OMOP common data model, you will see that all the tables have foreign keys to other tables. For instance, a person has a provider ID. And if you run the ETL, you have a dependency graph that is here on the right, that you need to follow, because you need to generate, for instance, a provider ID before you can assign that provider ID in the person table. The tables that are on the same level, you can run in your ETL in parallel to speed up the ETL process. The second stage of the rocket is all those event foreign keys, because those event foreign keys can almost point to any table in your OMOP. So you have to run like your full ETL before you can assign those event columns, and that's why we do it in 2 steps. Rabbit in a Blender also performs like a rocket, especially if you combine it with BigQuery, like we do. Our full ETL takes about 20 minutes, and we have for the moment 8 billion rows in our OMOP. That's quite a lot. Rabbit in a Blender recently, we also put in SQL Server support, because in Belgium we are working together with 8 other hospitals, and they are running mainly on SQL. Some of them SQL on-premise, other are running SQL in Azure. And in our case, DQD takes 2 minutes to run. What brings the future for Rabbit in a Blender? We want to integrate RS. We also want to integrate the query library. We want to look at an incremental ETL, because we are fast, but an incremental ETL is faster and cheaper, of course. And our first things that we tried out, we could get within 30 minutes our EMR data into OMOP. So that is our goal. We also want to integrate our Keun tool into it, and we want to integrate a GUI so that it's a little bit more low level to use. And that's it. You can contact us on the email below, and you can look at our project in our GitHub.
Awesome. Thank you so much. And thanks to all the panelists. I think that was a really fantastic way to start the day, and already spying lots of connections between all the different projects. So that definitely exceeded expectations. Thank you all so much. I'm going to open up the floor now to anyone who has questions. I hope folks have been taking notes and saving up all your questions for our panelists. So feel free to raise your hand, and I'll kind of try to take the questions in the order that we receive them. Don't be shy.
So Katie, that was great. It's really fun seeing some of the new trends. I definitely see the trend toward DBT, which I think seems like a really good platform. So I guess for Roger and Vishnu is there general, where can we put general support for folks who want to start embracing DBT within the OHDSI community? Is there a working group that meets, that talks about this? Where do you start collaborating on DBT?
So, Katie, shall I take this on your behalf and say?
Yes, go for it.
Katie set up a working group, Paul. Within the OHDSI community, there's a DBT working group that Katie's leading on. Roger, I, and a few others are part of it. Katie's put together what am I speaking for, Katie? Katie, you do it.
Sure. So we're not an official working group yet. It's kind of informal. Folks I've spoken with over the past couple of years who are DBT enthusiasts. If you are interested, there actually is a sub-channel of the open source community working group in Teams. That's not very active. I think we've been mostly using just a Teams chat between the 7 or so of us who have been having a couple of calls. But feel free to join us there in that Teams channel, or just reach out to me if you're interested in getting involved.
Excellent. And I guess my second question is to Roger. Have you taken your Epic scripts from, I saw that was on your list. Is that also available now, like you've released within the Epic Galaxy Web for using it with DBT?
I have not yet. We're still in the process of it. One of the things that I'm doing is I'm refactoring all of my queries. We don't have a single process that pulls the data and puts it into OMOP. We split it up into 3 processes where we pull it from the source into a staging area, and then we have a second process that pulls it from the staging area and maps it to OMOP. And one of the things I've discovered is to make it faster, especially using Snowflake, is to push as much possible into the pull queries or the pull models as much as possible. And so we're in the process of refactoring that. When I get that done, I plan to post, I think, the entire DBT project as it is, because it's just text files. I mean, it's just a folder with text files in it. I plan to post that up there. It's the code that I have been using typically for those that I posted on UserWeb was SQL Server, but now that we're using Snowflake, it's going to be in Snowflake. But it's relatively easy to convert between the two. So I will be putting that up there.
Yeah, so I guess I see 3 things now, right? There's the source data, Epic, Cerner, name your EHR. There's this data orchestration platform like DBT, and then there's the source or the platform database technology like SQL Server and Snowflake, right?
Yeah.
And so DBT is just an opportunity. You could use that DBT. You could use with any database technology.
Pretty close. Yeah, they've got tools. I have used DBT just to see if I could do it. I used DBT with SQL Server as well, so I was able to orchestrate that. And so, but
since that's in Python, is that using like PyODBC, or is that dependent upon other database connection tools?
You can use ODBC or JDBC with it.
Vishnu, you want to add something?
No, I was just going to add to what Roger said in response to Paul's question. Will DBT work with any database? I think DBT code comes with two components. This DBT core, the core library, and then you have an adapter, database specific adapter. So you have DBT Databricks, you have DBT SQL Server, you have DBT Postgres. So use the appropriate adapter. Now that also comes with a disadvantage in that if you've written a lot of your DBT code that is dialect specific, for instance, for on-prem. So our DBT transformation that I spoke about today, all of it that happens on-prem SQL Server, and there is some T-SQL in there. But once we prepare our OMOP database, that gets ingested into Azure Databricks, and our medallion architecture is getting built in Azure Databricks. So we use the DBT Databricks adapter for that work and the DBT SQL Server adapter for the on-prem work. DBT doesn't automatically do the dialect translation for you. And that's one of the downsides, I think, as a community, if we're working together. But if you all stuck to ANSI SQL,
yeah, it'll
work. But then you're losing out some of the goodness of T-SQL or Databricks. You can have Python models. That's the challenge. And I think that's one of the things that we're discussing in the DBT working group as well.
Yeah, thanks. Hayden, thank you for chipping in. Oh, I can't hear you if you're saying anything.
Yes, can you hear me now? So this kind of relates to some of the work I've been doing with the IBIS team, which came out of kind of a new startup, Voltron Data. It's a Python package, and kind of is headed by, if you've used the Pandas library, Wes McKinney is the kind of lead on it. And IBIS has probably 15 or so different backends. So it's a fairly extensive, it's a bit like dbplyr in R, but I think more extensive in the support of all the backends. So the query is written in Python in that kind of dplyr fashion. It's a very similar grammar. And then that is translated using some pretty well supported and maintained SQL kind of translators in the back end there. The team's been really responsive. I've liked working with them. I haven't put nearly as much time as I would like into kind of taking our ETLs and translating them over to IBIS or even kind of trying to look into how we can integrate IBIS to R, maybe with some sort of a smaller package. And obviously it adds Python as a dependency on some of things, which can be a challenge because you need the interpreter in addition to R. But I think it's a worthwhile thing to kind of keep exploring, and the team's really responsive. I've met with them a few times, and I've used them for some other projects as well.
Thanks. Any panelists want to respond or comment? If not, that's okay. There's some interesting stuff going on in the chat regarding IBIS and SQL Glut, by the way. And there's someone whose first name is A. Dahan, your hand is raised. Sorry, I don't know your first name.
Yeah, no problem at all. My name is Harry. So I'm from the Netherlands. Basically also working on some stuff with Darwin, etc. I've got a question. I think it was for Chandrabalan. You've mentioned that you run your OHDSI stack in Kubernetes, and I was wondering, how was that journey, and how did you experience that? And now you're running it for a kind of period of time. Is it doing what you thought it should do, and how is your operational phase in that? Because although it's a developers conference, I still think the ops part is also kind of interesting to know. So I was wondering if you could elaborate a little bit on that one.
So thank you. I'll admit we are early days with our Kubernetes experience, especially with OHDSI. So we've had Atlas and Hades running alongside Web API on Kubernetes for about a year now, but not really we haven't really used it in anger. We had the stack running in Kubernetes, but talking to our on-prem SQL server. So it was running on Azure Kubernetes service, but was speaking to our on-prem SQL server. And as long as you're not asking it to do a lot, like for instance, setting up authentication on Atlas is a pain. So, trying to get it set up at authentication on Web API proved to be a bit of a pain. So we're trying to iron that out. Right now, we've kind of refactored our entire Helm repository. I think I dropped a couple of links in the chat higher up, where we've refactored our Helm charts, and we are using something called Flux CI/CD to reconcile any changes to our configuration into our Kubernetes cluster.
Okay.
What we haven't gotten working is we haven't gotten Atlas working with Databricks yet. We haven't tried. I'm not sure if anyone else has tried. I don't think that's a function of Kubernetes itself. I think that may be a function of Web API on Databricks. So that's the next step. But we've got the synthetic database up and running, and it works with the Nomia.
Okay, cool. Thank you very much. Yeah, I will look at the links you've supplied with the Helm charts and FluxD with the GitOps.
Please get in touch. Please get in touch.
Yeah, and FluxD with GitOps operation, that kind of stuff also. We actually do have some kind of authentication on Atlas, so maybe we can collaborate on that one. Okay,
Yeah,
thank you.
I would just throw out there real quick, J&J recently started working with Databricks as our backend, and we required a few patches to Web API in order to work with Databricks. So there is a pull request. I don't know that it's merged into the main branch yet that updates the driver compatibility and fixed a whole bunch of problems. We're also finding issues throughout the stack, Achilles and elsewhere. So those are filtering in from our side as well.
Very quickly respond to that, Katie. Frank, that's fantastic. I'm just, I'll get in touch about that. We had a similar issue running data quality dashboard against Databricks. On Achilles, I think we had a little problem running Achilles against Databricks. So that's where DBT stepped in. And what we were able to do was take Achilles, get Achilles to generate a whole pile of Spark SQL, just raw Spark SQL. And then when we converted that into DBT, and DBT made quick work of it. So that's how we got around building Achilles on Databricks. But it'll be good to get these packages working natively.
Yeah, there's
mode. Sorry.
That's a good question. Was it SQL only mode that helped you go from Achilles to DBT? Okay. Yeah, so there are 2 pull requests in Achilles today for fixes that resolve issues with performance on Databricks and Achilles. So, but we're finding the same things.
I will also flag there's a kind of a turbocharged SQL only mode in DQD specifically that was written for Databricks. I don't know if you've seen this, Vishnu, but recommend checking it out. It apparently like 10x's the speed of DQD. We're also looking for folks to test that out on other platforms. So I'll share a link to that specific function in the chat. Okay, we don't have any other questions right now, but there's been some chatter about Python in the chat. So I wanted to ask Georgie, Sam, Peter, who are all Python developers, kind of what's been your experience as a Python developer in Odyssey, which tends to be an R-centric community?
Yeah, I mean, I guess the stuff that's in the chat about, what we're going to reauthor pieces of the tech stack. And I think I just look at it differently in the sense that if you're using, like, it's never an all or nothing game, right? And so if you're choosing tools for the specializations to which they are really supportive, then it's I don't think it has to be an entirely either or thing. Yeah, maybe I don't have as much of a voice on that because I'm a bit out of time zone and maybe can't be as active in all of the conversations, and so I'm maybe not missing out on as much as some people who are more on the core time zones. Anyway.
Anything to add, Peter or Sam?
I can't see the chat. I think my organisation.
Oh, I'm sorry.
It. No, don't worry. I think it's on our end, not yours. I was going to say, yeah. So most of ours is Python based, but I think our experience of we don't integrate tightly with any of the Odyssey tools apart from we use White Rabbit and we link into Athena as well. But I would say our experience is as long as there are well documented APIs, then it doesn't matter what the two languages are that are talking to each other.
Yeah, that's a great point.
Yeah, I can also not see the chat, but we re-implement, for instance, DQD and Achilles in Python because in its core you have the queries, you have CSVs that hold all the data. So yeah, we just do it that way, and it works for our tool.
Yeah, it's a good point that a lot of the core artifacts are SQL config files, which can translate across multiple languages. And I think also going back to Paul's schools of fish, what we're talking about right now is the data management school of fish. Really, the R-centric aspect of Odyssey is in the analytics school of fish. And I think everyone would agree R is not a data pipeline tool, it's an analytics tool. So in the data management school, I think we can feel free to Python it up all we want.
I think the other thing as well, using the ways of working that I've been doing, like if I do need to collaborate with somebody who has restrictions on what they can install and all that kind of stuff and has a lot more difficulty getting things running, like the ORMs do spit out, like you can force it to compile and give you the SQL that you can run that's equivalent as well, which can be quite powerful. And the other thing that's worth commenting on, I guess I spend most of my time also in the oncology working group space, so working with all the episodes and things that maybe aren't that mature in the rest of the stack either. And so again, it didn't make as much of a difference in the decision-making process there either.
Yeah, makes sense. Hayden, I see you have your hand up.
I guess I might ask, and this kind of pivots off of Python just because it's been one of my motivations for integrating any Python code. But within the stack, I wonder if the panelists have come up with either, I mean, mostly in R, but APIs that aren't, the projects maybe are not as reliable or are not as supported as they could be. I'm kind of thinking of this as like from an open source ecosystem, if we're building on APIs that are kind of outdated, or it's really hard to even just go into their repo and start working with them to get something updated. I'm wondering if the panelists have any that are kind of like on their radar of, these projects are kind of not quite as maybe they used to be when we started to integrate them. And I think overall, most of them are pretty solid, but I'm a risk averse person, so.
I can respond to that. I'll start off. So that's the nature of open source, isn't it? To some extent, that you can't be terribly risk averse, I guess. There are some open source projects that are super mature that are in our stack, like Jupyter Hub and Jupyter Lab. But within the Odyssey ecosystem, for instance, the Hades package is quite mature. Atlas is quite mature. But then you're taking something that's been built over 10 years, and we've decided to put our OMOP instance in Databricks, right? And if we want Atlas to work with Databricks, we have to put in the effort to make it work as a community. And so I'm a little bit low. Yes, I've run into a bunch of issues, but I can't complain about it because I haven't really gone and reported them on GitHub. If I created issues on GitHub or added to the documentation, then I could come back and say, hey, I'm happy to support. But I've kind of gone and worked around. We're a very, very small team. So there's a balance between, for us, the Odyssey OMOP community, what we've taken from the community has been phenomenal because the data that we've mapped into OMOP was not being used in the hospital. It simply wasn't. the knowledge about that data sat in the heads of a few BI analysts. Now I have a consultant surgeon, a colorectal surgeon, not me, a colleague writing queries against OMOP, right? That would have never happened 2 years ago. Now there are clinicians who are writing SQL queries on OMOP. We're working on large language models that allow clinicians to write natural language queries against OMOP. So all of that comes with huge risk, but hey, that's what open source is about, I guess. That's where I'm at. I kind of answered you in a really roundabout way. Yes, there's a bunch of issues, but the pros hugely outweigh the cons, I guess.
Thanks, Vishnu. Any other panelists want to chime in? If not, I do have some seed questions for you all. And audience, feel free to continue raising your hands if you have more questions that come up. But here's one that I think each panelist could answer. What is one piece of advice you would give to a developer who's building an OMOP ETL for the first time? And let's maybe go in reverse presentation order. So Peter, if you want to start, that'd be great.
Yeah, I guess make it as simple as possible, because you do not want that only data engineers can work with it, but also other people, because mainly data engineers don't have as much medical knowledge. They are very IT technical and data technical. And if you can make a tool very simple, then you can have collaboration of people with more medical knowledge that will assist in your ETL journey. So,
very good advice. Sam, you want to respond?
Yeah, I totally agree with the previous answer. I think I would chime in something similar. You know, make if you're going to build it, at least check that there's not something out there already. That you know, and could you collaborate with them rather than rebuilding your own thing? But more on the theme of what Peter was saying. Yeah, I would resist trying to build the ETL tool to end all ETL tools. Have a clear idea in your mind of what it is you actually want to do. Who are your users? So for in our case, we're working in the kind of research data field on certain types of data as well. So we made the decision we weren't going to implement certain tables in the CDM, for example, just because we knew they would include added complexity that maybe we'll need them in the future, but right now we don't. So yeah, don't overcomplicate it.
Great, and that's one of the points of this panel is going to your first response. Don't reinvent the wheel. We've got 5 amazing projects here that you can use to get started with your ETL process. So lots of great resources already available and folks willing to collaborate too. Georgie, want to go ahead?
Yeah, I mean, I guess mine's sort of a variation on a theme in a way, but yeah, I think the thing that I wish somebody told me at the beginning is just pick a thing and finish it, because I think it is about the simplicity and it is about exactly what everyone else has shared, but also getting the value of having those data in a harmonized form in front of the end users as rapidly as possible and giving them access and like iterating the process is a lot more effective than trying to kind of boil the ocean and have everything in a really nice, beautiful little box, which I quite like and it's very satisfying. But yeah, don't do that.
Well said. Roger.
I've got 2 things. One of which worked out really nicely for us at Corewell Health with the All of Us is that we were developing it with a limited data set, like 10,000 patients. And so we're not trying to swallow the whole ocean or build it against our entire patient population. So I would say start with a small but representative patient population. But the other was, I alluded to this a bit in what we're doing is I started my first iteration through this, and I've posted these because it's Epic specific. I can't post it anywhere but on the Epic user web. But if you're an Epic site, I do have my entire code base in actually three different versions. My first version, everything was monolithic. So I was pulling, like for conditions, I was pulling it from Clarity, mapping it into the same code and exporting it. And what I discovered is that it was much better to be able to modularize that a bit. And so, like I said, I have it in separate modules: pulling, mapping, and then writing. So I would recommend that to modularize it as much as possible without going overboard with like variables, to try to make it so complicated. The way I've done it, there's a bit of redundant code that could be made much more elegant by reusing it and putting in variables and stuff. But it's a lot harder for somebody else to figure out what's going on. So there's a need to keep a balance between elegance and modularity. So.
Thanks, Roger. Vishnu.
All right, so don't make OMOP when I have partners also mapping to OMOP and they talk about OMOP. Hey, we want to get to OMOP, we want to get to OMOP. But our strategy has been, enjoy the journey as much as possible, and I'll try and describe it a little bit better. So I've got Quinn, she's just left. Quinn's doing a PhD around data engineering. How do you take your source data and put into OMOP? Now, so we've taken a more kind of research scientific aspect to mapping data into OMOP. How can we do it quicker? How can we do it more collaboratively? How can we bring our refresh time down from a month to a week to a day? And all of that has allowed us to solve several data engineering challenges, right? I think Sam mentioned OLAP. I went and learned about column stores. dbt materializes your tables not as column stores, and column stores bring phenomenal performance and size gains. So if you have people within your team who are on an academic degree, they're doing an MD or a PhD, emphasize the importance of data engineering. Yes, the data science that happens on top of OMOP is important, but the data engineering itself can be an academic exercise. So it's encouraging that role. And also, I think this may be more, I don't know, maybe I've got a slightly tunnel vision view of what's happening in the UK. There's a lot of talk about OMOP and not enough talk about the OHDSI stack. So I think, Sam, I don't know what your experience has been working within HDI UK. I hear a lot of conversations about OMOP, but not enough about OHDSI and the infrastructure. How do you deploy infrastructure? Things we've spoke with Frank about Web API, talking to Databricks. I don't think there's, if there are conversations happening, I don't see it. So two pieces: talk more about the OHDSI stack in the UK, and then data engineers are crucial to this, and take a more scientific approach to it.
Great. Let's see. We've got about 5 minutes left. Does anyone else have questions? Because I have one more that I could throw out there, but I want to give folks a chance to chime in if they have any remaining things to ask. Sam, yes.
I was just going to come back to Vishnu's question there, which I think is totally fair in my experience in the UK, particularly around things like the SDE network and the push towards OMOP. I do hear very little about the OHDSI stack, both within and without Health Data Research UK, which for folks who aren't aware, it's kind of like a pan-UK, it's not a funding council, but it's kind of like a research body that is overseeing and corralling that whole area across the UK. But yeah, so I would say there's, in my experience, very little understanding of the OHDSI stack. So maybe that's something to work on.
Interesting. Do you guys think that's an awareness issue or kind of accessibility issue more?
Certainly, it starts with awareness in mind.
Okay, so my last question for you all, I'm going to combine two that I had in mind, and we can, I think, quickly go in reverse order. What OHDSI resources did you find the most helpful while working on your project? And on the flip side, in what areas, if any, do you think the OHDSI documentation and support could be improved? And we'll start with Vishnu and then go back towards Peter to wrap us up.
The most useful OHDSI resource, I think, the community. We're talking about the people and the soft skills, if you like. If it's just one piece of software, I think it was, for us, it was Usagi, because anybody who's done vocabulary mapping will tell you how painful and laborious and it is. Usagi was very useful. What could be better? I think we have stumbled upon documentation that we wished we'd stumbled upon 6 months or 8 months previously, because documentation is fragmented across, and that's the nature of open source, right? I'm not complaining about it, because I've not contributed to it. But getting the documentation organized a little bit better would be lower the. We spend ages sometimes, and then suddenly discover, oh, and it's like, how long has that been there? It was for the last 5 years. We just didn't find it. Okay, so getting that in one place would be really good.
Yes, common problem. There's lots of great stuff out there if you could just find it. Roger.
To follow up on Chandra's note there, the themist work group is actively looking to pull the themist issues into a single source, and that is going to be a huge resource for people, because the advice about how to use OMOP and how to fill in the ETL has been scattered throughout a number of different places: the wiki, the work groups, the online forums, and they're pulling that all together. So that, I think, is going to be huge. For me personally, the OHDSI tool I used the most was Usagi, and that's the same answer to the question that to your second question, which was the one that needs the most improvement is Usagi. And so I would say that is both. Also, I used the online Athena extensively.
Thanks, Roger. Georgie.
Yeah, I mean, I think one of the ways that, again, I can only speak to my experience in the oncology working group where I've been most active. And I think one of the things that has been patchy, but is definitely getting better, is a move to, if there's a decision point taken in a meeting, or if there's an open question, those kinds of things, instead of just assuming that everyone who is interested was there, being really diligent about documenting those in the GitHub has been the most useful. So getting organized into projects and sprints and that kind of stuff, so that we can do that asynchronously. Again, I have personal bias, obviously, which and like I understand the need for the forums to be a format that is used for question and answer and things like that, but that's the one I've had the hardest time with, because things get very stale and sort of off topic a little bit. And so pointing at actions and activities that actually solve the problems in the Git. But that's hard because it's very, it requires you to be a little bit on the inside to be using it. So that's obviously the forums need to stay in their current format, but that's my hardest space, I think, to operate in.
That's a great point. Thanks, Georgie. Sam. To be frozen. Oh, you're back. Okay, good.
Sorry. Yeah. I think I definitely pick up on the theme of the importance of documentation, like bringing that into a single place. I think is an excellent idea, particularly with an eye to kind of bringing more people in, like in the UK context. If you want people to know about something wider than just like the OMOP CDM, all of that, having a single place for them to sort of go to, I think would be really excellent. And whilst there's kind of lists of the many tools, being able to kind of see where they fit together, I think would be really excellent. Maybe that resource is out there, but again, I don't think I've seen that. But yeah, the tools that we use, extensive use of Athena. Again, I think that's really excellent, and we use White Rabbit in our pipeline as well.
Great, and last but not least, Peter, to wrap us up.
Yeah, I have a developer background, so I mostly start a little bit awkward. I read the code and afterwards the documentation. So for me, reading code is like reading documentation. So that's the strength of open source. The code is available. But colleagues of mine who like do the mapping and other medical stuff, they're getting their answers is not that straightforward. You have to ask at the forum, look at splinter documentation, so that can be. But as developer, yeah, I think it's good.